Hello guys, I am Erika Sinadjan, and my topic for today is calculating molecular mass and balancing chemical equations. So let's start with defining molecular mass. So what is molecular mass? The molecular mass of any compound is the sum of the atomic masses of all the atoms present in one molecule of that compound. So it states here that the molecular mass is the sum of the atomic masses of all the atoms present in one molecule. So I will provide to you the example of molecular mass. So the problem here is a cancer patient needs to increase his sugar or glucose intake to fight cancer cells. So it is C6H12O6. So the question here is how many moles of sugar does he need to complete the doctor's prescription of 13 grams of intravenous sugar and every day for 1 month. So it asks here the mole of glucose. So how many moles of glucose? So first, what we are going to do is calculate first the amount of atoms in one element. Let's so first is the carbon. So carbon has 6 carbon atoms in C6H12O6 or glucose. So there are 6 carbon atoms times the 12 atomic mass, which will equal to 72 grams per mole. Then next would be the hydrogen. So hydrogen in glucose has 12 hydrogen atoms. So it will be multiplied by the atomic mass of hydrogen, because we all know that hydrogen has one atomic mass. So it will be calculated to its atom in glucose. So in hydrogen there are 12 grams per mole. So let's proceed to oxygen. So oxygen in glucose has 6 oxygen atoms. So it will be multiplied by 16 atomic mass, because oxygen has atomic mass. So it equal to 96 grams per mole. So sa inani diri we determine we already determined its molecular mass, so which is 180 grams per mole. So let us calculate now. So the given problem is the doctor's prescription is 13 grams of intravenous sugar. So first let's put here 13 grams of C6H12O6. So let's calculate it with with 1 mole, because in every mole there is 180 grams of there is 180 grams per mole of C6H12O6. So by calculating it, there is 2.17 mole of C6H12O6. So that is the answer. There are 2.17 moles of sugar. So there is 2.17 moles of sugar. Then the next question is how many molecules of glucose does he need every day to fight cancer cells? So this it asks here the molecules. So we already know that C6H12O6 has 180 grams per mole or molecular mass. So let's calculate it we already know that 13 grams times the times 1 over 180 is 2.17 mole, and it asks here the the molecules. So times, so let's multiply it by 6.022 times 10 to the power of 23. So what is this number? So 6.022 times 10 to the power of 23 derives from the Avogadro's number, which is this, because in every mole there is a constant number of Avogadro, so 6.022. So that is equal to 4.35 times 10 to the power of 22 molecules of glucose, or C6H12O6. So that is the purpose of molecular mass, that is to sum all the atomic mass in of the compound. Next would be the balancing of chemical equations. So in balancing chemical equations, it must contain the same number of atoms of each element on both sides. So in every reaction of a chemical, so in every chemical reaction, there is always there must be a balance. There must be a balanced amount of atoms. So let's take an example of aluminum. So aluminum reacts with sulfuric acid. Sulfuric acid is H2SO4. So their products are hydrogen gas and aluminum sulfate. So this reaction is a synthetic. This reaction a um, is a is shall we say, this reaction is a single replacement reaction, or the displacement reaction, because um, the product is the product is replaced by another element, that is aluminum plus H2SO4 yields yields aluminum sulfate plus hydrogen. So this the element the element which is the hydrogen is replaced by the aluminum is replaced by aluminum, because aluminum has greater activity series than hydrogen. So that is why it is single replacement reaction. um so so let's hear. So the equation here is unbalanced and reaction. So we can already see that um, aluminum on the left side has no atom, compared to the right side, which is there is 2 atoms of aluminum. And and one tip in balancing chemical reaction is to determine the is to determine the to pick out the most complicated looking formula. So the most complicated looking formula here is the sulfate. So the SO4, which has 3 groups. Um, that is, so the first thing that you must do is the find the so the aluminum here on the right side has 2 atoms. So on the left side, the aluminum has no atom. So you will put on the left side the 2 atoms of aluminum. So On the second equation is you put two aluminum atoms. So as you can see, aluminum on the left side and on the right side is equal na. And the next thing to do is you will locate the SO the sulfate. So all sulfate has three groups. So three, and on the left side, there is no groups. So sulfate has no group. So or there is no